How's it going, everyone? Welcome. Little Gonzalez here, and today let's going to explore now at the Git. What is this concept, especially of merge and rebase? And then we're going to now explore at the working with remote branch, which is pretty straightforward. It's not that hard. And then we move on to conflict resolution. Now, to make this quick, to make a quick overview of this. This is a very short course taught by the Pranjing, a software engineer that has previously worked, I think that he's currently work at the Netflix, right? Where we went through over these three parts, and now in today's video we're gonna look at working with remote repository, and then started to look at how can we solve this conflict resolution. So a quick intro is that this is a tool that was invented by Linux Torvald as a way to now give us the ability to keep up his pace, because now we as mere mortals, we just only can aspire at what he can achieve. What does it mean by that is this is also the role of a lot of tech lead, is at some point you will have the entire system on your head. That's the whole point of this. So that's the point of tech leads, and also why a lot of tech leads, especially if they're holding a system that is not generating revenue, or at some point is burning a lot of money, a lot of cash, is quite not that useful. Now, with that, we also look at what Git is all about. This distributed version control system, which is a fancy way to say, hey, I have now a local copy of the project in itself that is stored on the server, and then here I can apply my change, and once that is done, which is something that we're gonna do here, we're gonna look at how to do that, working with remote repository, then we can now submit our change, and then, well, actually solve this conflict that may arise or not. So we also look at some Git tool techniques, but this is the TLDR and why it makes this so powerful. And at the end of the day, Git, we look at the architecture of this, which is a decision that were made before you for those who develop this tool as a way to now use it. And what is the end goal of this? So the architecture in Git is now laid out on porcelain and plumbing command. We're gonna explore is at least 14 porcelain commands, and then of the we're gonna dive deep into some of the subtle plumbing commands. The whole point of this course is that we can now learn what is the data structure that Git is using behind the scenes. So anytime that we need to do a rebase, merge, or cherry pick, all right, we can actually know what's going on behind the scenes. So this is when we look at concepts like repo, which is the Git, the project that Git is the Git, the project that is being tracked by Git. Okay. Also is the different areas that Git now pass these files onto the final stage. In other words, into the commit phase, which is from on track, and then it passes through staging area, and then that is moved once you make a commit to the track area. Another concept like working tree, what you're going to define is your environment where you're currently at, and also the commit, which represents the entire state of your application at some point in time. That is contained is now is initially, if you create a repo, you do git init, it create now which is part of the Git basics, it create now a folder under the Git, hidden folder, right? Where it allows you to now is where now Git is gonna use this as a way to keep track the different state change that you made, that you do in your project. So because anytime that we now create a file or do some change and then we add to Git and then we commit with a message, what happened is that now Git create is a node, that this node, if this is the first node, it only has a tree, author and committer. And the tree property is just the easiest way to think about this is the folder structure, where it has now a commit that if you want to know what this commit is, we can also use the git cat file -p and pass the commit. And this commit is just a SHA or secure hash algorithms that now it is a 40 length characters, where it can tell you is the what is the content of this commit. And when you look at the content of this commit that you generate initially, all right, it now has a reference to the file as well as the name of the file, and also another commit that when you want to inspect what this commit is, it now contains is the content of that file. And this is the path walking through what is doing behind the scenes when we commit a message or when we commit changes in Git, all right? And this is actually quite illustrative and a very good exercise, so you can now understand what's going on behind the scenes, right? It's a good thought experiment, a good thought exercise. Now, because of that, all right, then we look at what's happened when we now create is a branch, and the different or the techniques like merge and rebase. Anytime you create a branch, is just now a reference that gets stored on a folder, which contains now the commit, all right, that is pointing to that commit at the time that you create that branch, right? It's just a pointer to that. And if you're not creating is based on this branch, more changes along this, and if your branch has different history, so merge is a way of how you can combine two different histories into one by looking at the most common or the best common ancestor known as the common base, and then replay each one of them to see if there are any errors or to see if there are any conflict in there. If it is, they will suggest now when it create a commit, hey, please solve these problems. And this is important because when that happens, when now Git show you, for example, a message input, is because now at some point those two branch has different stories and it wants to conciliate, wants to merge them, right? What happened is that if, for example, they have the same history, if these two branches has the same history, like this, all right, so they don't diverge, if they have the same history, so what it's doing is now a fast forward. It's like usually it's now updating the pointer up to the tip of that branch. So there's another alternative known as Rebase, where Rebase allows you to now is move that branch, okay, to the tip of another branch. Let's say you now have diverged here. So Rebase say, even the name is self-explanatory, Rebase say is like, hey, whatever branch you want to move, I'm gonna put it at the tip of that, right? So I'm gonna put is now the current branch that you are to the to point to the tip of the branch that you want to rebase. So this is also an example of what we did here. Let me just show you this with rebase and that kind of stuff. So for example, here with rebase, exactly. I want to now is update this. So what it's doing here now, rebase, let me actually recap about this. What is rebase here? Rebase, exactly. Rebase here. There you go. Yeah, give me a second. From the following image of a rebase, what we are updating or what we are resetting is the base commit from the source branch, which is full rebase, full rebase strong, to point to the tip of trunk and replay each commit on top of that, right? Exactly. So what you're gonna is say, hey, let me take now the current branch, create a temporary a temporary folder where I'm going to hold that branch, and then I'm going to reset the base of the commit of that base branch, okay? And then I'm going to update that, and then going to reset to point to the tip of the branch. So I'm going to reset is the base. I'm going to resetting is, and I want to show you this because I think this is quite important. Like this. I don't know if you are quite updated right now. What about now? Exactly, here we are, right, with the rebase. So what we're doing here with git rebase, we're saying it's like, hey, let me know this current branch. I'm gonna create now a temporary file, or we're gonna create now a temporary storage of all of this commit at this branch, and then I'm going to reset the base commit to point to the tip of the trunk, all right, to point to the tip of the trunk, and then I'm going to now replay all of these different commit from this branch, so you can now solve any conflict here. What it's doing here is effectively creating now a new history. You are rewriting the history, and this is something that is very dangerous. Why is that? Because if you do that in a public branch, you're gonna blow up for everybody. You know, you have now a problem. So you break that for everybody. So you have to be very careful about that. So the TLDR of this is that you use Rebase. This is part of the useful stuff, recapping all of this kind of concept, and based on the prime experience is like this, which is great. It's like, okay, it makes a lot of sense for you to now take this nugget of wisdom, which is if you're gonna use Rebase, do that in your private repo, in your private branch. If you need to add some changes to the public branch, use a merge. So far so good, right? So far so good. Now the mystery is now clear, you know? So anytime that you see what Rebase is doing, or a merge is doing, something that is right above, all right? So you know what's going on behind the scenes. It's not magic. It's just a series of logical steps that is doing behind the scenes. That the beautiful stuff of this is that when you understand that, then you realize that there is something magic here, because the more the more commit you have, the more changes you add to that particular repo, all right, and the longer your history is, of course, the more memory is used. But again, it's storing that in a very memory friendly way, in a very effective and efficient way. Because it's storing all of this file in a binary large objects, this blob, okay? But remember that the commit contains now is the entire state of your application, which means that it contains all of the file that you add at that moment, so you can recreate your project entirely. So, because if you have a long Git history, a good command is that you're gonna, anytime that you clone something, you say git clone, and I think this is dep 1, it only gives you is the last commit that contains the latest change of your application. And that's something that is quite important, especially if you're going to build with this large application, large scale applications. So that's good. That's good. That's completely good. Now, what we're gonna do in today's video is to explore now at working with remote repositories. So let's get into this. Working with remote repositories. Got it. And here we are. There's also another commands they are not quite irrelevant, but in fact they allow you to now is cherry pick commits. So for example, head and ref lock. Head it's now pointing to whatever branch you are currently at, right? And this is great. This is awesome, right? And just head just contains a reference path that has a SHA commit. So it's pointing now to the last commit at that current branch that you are. So why this is important? Because with head, all right, and with ref lock, which now is just a record of where your head has been, so you can use now, for example, to bring from the dead some old commits, which is exactly what we do with ref lock and cherry pick exercise, which was quite interesting because let's say you for some reason is now delete that branch, right? So you delete all of the commit that you did that by mistake. It's like, oh my god, I did that. So you can now have access to the logs of heads and then using reflog to actually prettify that output, so you can see that much more in a human readable way. And that is interesting because by using this cherry pick, you can now is take that single commit and replace into your branch. So of course it requires that your working tree is clean to use it. And this is why if you do small changes for this, man, if you do small changes, you can cherry pick those commits and replace into your branch. This is the reason why we need that you to apply these small changes to all of this, because it allows you to, for some reason, is recreate this changes. To recreate the entire project of that, and that's quite interesting. So now let's go to working with remote repositories, which is this one. There you go. Remote git and fetch. So remote git and fetch, pull and push. So there is pull and push. Okay.
That have been created by our fellow frenemies. Frenemies, of course, is because they make code and it hurts your feelings, or
often we need code changes that have been created by our fellow frenemies, nuestros enemigos.
hurts production's feelings. And but how do we get their changes into our repo? How do we push our changes to their repo? Here's one thing that kind of, I guess, will surprise most people, is that it doesn't have to be remote. It doesn't have to be on GitHub. I know that might be strange because often when people think of Git, they think of GitHub. They don't actually think of Git as its own thing and then GitHub as a means to store Git. They think of GitHub as Git.
Exactly. So Git is a place to store your files. Just that GitHub or Bitbucket, just that GitHub, Bitbucket, or GitLab, exactly, or GitLab, use their servers to allow you to store, exactly, user servers to allow you to store their so user servers to allow you to store their project, to allow you to store their to allow you to store your project into their, yeah, to allow you to store your project.
So you may have never really used Git as a remote. Like, you just probably have never done this. Why would you have the same thing twice? A remote is just simply a copy of the repo somewhere else.
So a remote is just a copy of the repo in somebody else, in somewhere else, somewhere else.
That's it. So I want you to create a new folder wherever you create folders. And let's call it remote Git. And I want you to initialize it with git init. So I'll jump in here and go, I'll go my personal directory. I'll make dir remote Git. And then I'll go into remote Git. There we go. And I'll go git init. There we go. It's its own repo right now. Remember, this is distributed version control, okay? The files can be on other people's computers too.
So we created another repo.
Or remote. Let's call it remote Git. Repo somewhere else. That's it. So
this is another problem.
I want you to create a new folder wherever you create folders. And let's call it remote Git. And I want you to initialize it with git init. So I'll jump in here and go, I'll go my personal directory. I'll make dir remote Git. And then I'll go into remote Git. There we go. And I'll go git init. There we go. It's its own repo right now. Remember, this is distributed version control, okay? The files can be on other people's computers too. And so let's add a remote. To hello Git. So adding a remote goes git remote, add the name of the remote, and then some sort of URI of some sort. It can be an SSH item. It can be just a path on your computer. So let's add hello Git.
So create a new repo. Let's initialize with git init. So let's get into this. We're gonna create now a new repo here called, here we say, hey, remote git, make dir remote git, and cd remote git. You got it. Pretty straightforward. And the other is a problem. We got now another problem, and that is, well, this one, a problem. Add git hello as a remote. You should name it origin. Oh, add hello git as a remote
As
origin.
the remote. By the way, you should name it origin. Typically, good practice is the authority repo is typically named origin. So I'll do it right now. I'll go git remote add origin, and I'll just literally go back.
This is interesting because it's any remote repo or any folder, local folder here. You can say git add remote origin, which is the name, and we go back and say hello git. So we need to keep track of this.
Hello Git. I can check it out with git remote -v. There we go. You can see that the other repo is just simply a relative file.
Git remote, my bad, add origin here. They say it doesn't exist. Hello git, what? Oh, it already exists. Git checkout git remote v. and I have this. Okay. So what I can do is say git remote add new origin, and then I go to hello git, right? It's just a convention. It's just a convention. So there you got it.
So hopefully everyone did that. Git remote -v will just verbosely list out all of your remotes. You can also just do git remote, but I don't find that very useful, right? Like that I didn't do anything there. And so if you do the -v, it'll also give you the path. So if you have GitHub, you'll see the GitHub address when you do a -v. Gitisms, typically this is how I set up the naming for my repos, is if I have only a singular authoritative repo, meaning that there is mine plus the one I'm pushing up to, say on GitHub, then I'll call that one origin. If I have a fork of the authoritative repo, so this is typical when you're at like a job, you have your main one and then you have your fork. I typically call my fork origin, and the authoritative one, the true one, the one true repo, I call that one upstream.
The two naming conventions. Naming conventions. Okay. Typically when you have a Git repo, it's called origin. This is the source of truth of your repo. Remote is your fork of some other repo. Sometimes you have your remote repo fork, okay, which you will name origin, and you have the project repo, which is typically named upstream. Conventions. So name conventions.
And you'll see that a lot. People will call it upstream. Sometimes instead of using origin, I use me because it's just, I don't know, it's kind of fun. You know, git push me. You know, it's fun. I just thought it was, I just think it's stupid and fun. So there's me. That's what, you know. And so that's kind of like my general naming convention, is to use origin for the authoritative one, unless if it's a personal fork, and then do upstream for the authoritative one. All right. You'll notice our default branch remained. It's trunk again, right? We didn't set the option again. We didn't do anything. It just keeps on remaining. So now trunk was yet again, even though this is a very different trunk, this trunk right here is from the default naming. Now we need to merge the changes from hello git into our new repo remote git. So we're gonna do that, but first we need the fetch. We need the fetch because we want to be able to get all of that object information from hello git. So if we go here and I go find git, you'll notice that it's just, again, this pristine empty one. Whereas if I do that in hello git, find git, it has, well, it has a lot of stuff in there, right? So I want all of that in remote git. So to do that, you need to be able to execute git fetch. Git fetch will fetch your remote's changes, and it'll put it inside the git state management. I bet you can even find where it stores things. So I'll go like this: git fetch, and you'll see git fetch will fetch your remote's changes, and it'll put it inside the git state management. I bet you can even find where it stores things. So I'll go like this: git fetch, and you'll see, look at that. I got bar, I got foo, rebase trunk, foo, trunk merge foo. We got all of those branches when I did that fetch.
So if I say is git fetch from the origin, in our case we need to specify what origin is, which is new origin, because we have several other origins, right? I don't want you to say that and look at that. But let's go here, okay? Let's go to this, and okay, so let's go to this, and then do this one, git remote at origin new origin. Say git from here, I want to say git fetch a new origin. So what I want to do is to fetch all of the entire history, git history, from that remote branch, other file, right, or a file directory, or the path file, or any other a computer, by using its HTTPS or SSH that fetch me all of this git history to this. So if you can see, if we now look at the find, for example, find.git, oh, it's because we need to initialize this repo. Yes, init, right? Now, if we did this, of course, gonna see this, right? A clean and pristine. That's what it is. So it's a git init, right? There you go. So we have now a pristine state, right? And if we find the git, the hello git, right? So you have now all of the entire state of the application, all of this history from Git, and that's what we wanted to fetch to this. Say Git fetch. Before doing that, I want to now show you say Git log. So there is no your current branch main does not have any commit yet. That's right. So we can just only show is this, say Git, right? Run that. Git init here. Say finder. So just to double check the .git folder in our remote git repo, okay. And now let's go to fetch those changes, or let's go to fetch the git history, because of what we do in git history from origin, okay, from origin to our folder remote remote git. That's what we are fetching. We're fetching is the git log history.
Okay, cool. So now I'm up to date, right? Right?
So if I say now git fetch new origin, new origin does not appear to be a git repo. Oh, because I need to add that at remote new origin with this hello git. Yeah, oh my god. Git remote add new origin. All right. Like this. We initialize git. All right. And then when we say git fetch the new origin, look at that. We already have this. So we fetch that, and that was pretty straightforward. Okay.
No, great job. All right, I love this. This is fantastic. All right, so let's use git log and verify that the remote trunk has been correctly merged into our git state. So I'll go like this, git log. Oh, our branch doesn't even have any commits yet. So our trunk is still diverging from hello git. And the reason why is we've only fetched the changes. We haven't merged the changes into ours. We haven't updated anything. That's why often when you pull, you'll see update with fast forward if you have your main line, because you don't make changes to your main line because you're all great engineers. I can tell right away. No one's doing that, right? No one's doing merge, right? Okay, so anyways, right now we haven't updated anything. Okay, so that means we need to do something, but by the way.
Exactly. So it only changed that we haven't synced with this. So we fetch all of this, right? But we don't have any commits there. That's interesting. That's very, very interesting. Once you fetch that, do we have the local changes? Right? So this is one of the reasons why most of the time when you fetch, you do a fast forward. Interesting.
Hey, remember, you can always do a git log. So I can go git log origin name, sorry, not origin name, remote name, which is origin, and then do any branch name, right? Because we fetched everything in, so we can actually see the log of other remotes. So I can go origin trunk, and there we go. Definitely my best work at the end of this. It's fantastic. XYEDA. Awesome. If you did one line, I actually pasted one line in there. I pasted the wrong thing in there. I actually executed one line. That's what it should look like. All right, awesome. If you did one line, I actually pasted one line in there. I pasted the wrong thing in there. I actually executed one line. That's what it should look like. All right, awesome. You can validate this is true by, when you look right here, you'll notice that trunk is 9B6E43. I can go to hello git and do git log 1 9B6E, same commit SHA, right? It now exists on 2 computers, or in 2 repos. So there we go. Okay, we are now kind of in line. If you wish to see what branches came down with git fetch, you can do git branch -a. So if I go back to remote git and I go git branch -a, you'll see all branches. And so the ones that start with remotes, those are all the remote branches. Then you'll have any of your local ones. Right now we have nothing. We just have the default empty one that has no commits to it. So we have no branches effectively, and just a bunch from the remote. All right, so let's update trunk with origin trunk. And then let's use git log to see those commits have been merged. So what do we do here?
Origin trunk.
We can git pull origin trunk, true.
Yeah, pull.
We also have merged. So what do we do? And just a bunch from the remote. All right, so let's update trunk with origin trunk. And then let's use git log to see those commits have been merged. So what do we do here? So we have no branches effectively, and just a bunch from the remote. All right, so let's update trunk with origin trunk. And then let's use git log to see those commits have been merged. So what do we do here?
Origin trunk.
We can git pull origin trunk, true. We also have all those changes. So we can just git merge origin, the remote, trunk.
Now we do a fast forward for this.
That I've merged those changes from my internals, which I just got done fetching from another repo, I can use git log 1 line, and look at that. My trunk now points to the same spot that this trunk does. And look at that. My trunk now points to the same spot that this trunk does. Got done fetch origin, the remote, trunk.
If this is to actually update that to say git log, well, you say you don't have any match, but if you say now trunk, and then you say, okay, I want to get branch all, right? And then I want to do it with trunk. Okay, say git switch to trunk. All right, so I say git log. I have all of my change, right? And then you got it. You got that with trunk.
Now that I've merged those changes from my internals, which I just got done fetching from another repo, I can use git log 1 line, and look at that. My trunk now points to the same spot that this trunk does.
because they don't have any main for that. They don't have any main, they have this trunk for that.
All right, so you can also use git pull. Fetching is always a good idea, keeps everything up to date. I always try to fetch often, see when changes happen, and then pull in any changes I want. Git pull is just like a convenient form of what we just got done doing. Fetches the changes and then merges those changes into your branch. And so you can do git pull, the remote changes I want. Git pull is just like, all right, so you can also use git pull. Fetching is always a good idea, keeps everything up to date. I always try to fetch often, see when changes happen. And all right, so you can also use git pull. Fetching is always a good idea, keeps everything up to date. I always try to fetch often, see when changes happen, and then pull in any changes I want. Git pull is just like a convenient form of what we just got done doing. Fetches the changes and then merges those changes into your branch. And so you can do git pull, the remote, and then the branch name. And you can also, for convenience, just use git pull, and it will use the current one. Back in the day, like 15 years ago or whenever I started using git, when you'd use git push, it'd push all of your branches up. It was fantastic. It would just send everything. So when you were just on your own branch and you get pushed and you had changes to the main line, you actually just got done updating the company's main repo with no testing or anything. Oh man, those were just the days. Absolutely a lot of fun. And so, let's add one line at the end of the README in hello git, and with the commit message, a remote change. But before you do that, I've noticed something, and I want to make sure we don't have any accidents. If you merged or cherry-picked changes into your trunk, you will have this extra commit. And I just want to make sure everything goes swimmingly from here on out. So if you've done this, has everyone done this, right? Okay, because it will diverge slightly from what's on the screen, because I didn't include that when I was printing everything out. So if you've done that, it's okay. I just want to make sure you know that it's there. And so if it's slightly diverging, there's no problems. All right, so let's add the one line at the end of hello git on your remote trunk. So I'll navigate over to hello git. I will echo in a remote change as the last line of README. At this point, it becomes important to make sure you're doing the same changes, because we're going to kind of get into some trouble here soon. So I'm going to go vim README, go all the way down to here, add this in, add it, commit it, a remote change. There we go.
Okay,
hopefully everyone did the same thing to hello git. I did not use status. Remember, again, it is good practice to use status. Since these are so trivial, I probably won't use status all the time, but typically I never git add without doing a git status. And for those that don't know, git add dot adds every file starting at my directory that git can find that has changes. So usually you do like git add a path to a specific file, but for convenience you can do git add dot, long as you have a good git ignore setup and everything's really, really nice. All right, now we're gonna execute a git pull on the remote git. So I want you to open up remote git and just go git pull, right? Because we have trunk in remote, we have trunk in hello. Hello has been updated.
Execute git pull in remote git. Okay.
We just want to pull in the change. It's going to error. I want you to tell me why it errors. So I'm going to switch over to remote. I'm going to git pull.
So it says that there is no tracking information for the current branch. Oh, and it's because it tried to pull that to this. There is no tracking information for the current branch. Please specify which branch you want to merge. Oh, okay. It's pretty self-descriptive.
The error is pretty simple.
Yeah.
It's just because you have a branch named trunk doesn't mean that Git's going to just magically assume that the trunk on another branch is the same one.
You need to
have
be
to set
clear.
tracking information. You have to tell Git which remote are you linking this branch to, because you could technically have a bunch of remotes. Which remote should it choose? And so you have to have some sort of way to set the exact thing that you're tracking. And so the easiest thing for us to do is to take this line right here with git branch, execute it, and we have origin, right? We only have one remote. And it's literally saying git branch set upstream to origin slash trunk. And I'm going to do it for branch name trunk.
So this will be now as
so now that I've done that, I can now pull in those changes. Because now it knows when I execute git pull, it now knows where to pull stuff in from. And back in the old days, git pull would just pull all the things, right? I'm glad those days are gone. Man, did I mess up some serious repos back then. All right, so hopefully you can think about GitHub now, and you realize what GitHub is. It's just your repo on someone else's computer. That's all it really is. Like, we're doing the exact same things you'd be doing with GitHub, except for we're just doing it locally. And so again, hopefully the magic is now even less. Now there's specific ways in which you can communicate to GitHub that we're obviously not doing here, but it's less magical. All right, so what about Rebase? Well, typically whenever I pull changes in from my authority repo, I prefer to rebase the changes in.
So typically when I pull in change from the remote repository, remote authority repo, I will rebase the change. I do not like adding it a bunch of merge commit, and this is a personal preference, but I think it's a superior one.
The reason why is that, again, I like a nice clean history. Any changes I'm making, I prefer my changes at the tip, because if I want to do testing again, I don't want my changes somewhere deep within the history. I want it exactly at the end where I can edit those, I can squash those, I can change them. They're still my changes until I commit them to the public repo. And so that's how I like to live. I think Rebase is the best. We'll go over sort of why it's the best. I know it's my opinion, but I believe it's the correct opinion. Also, it doesn't really matter whether you use merge or rebase. If you have a long-lived feature branch, life sucks. So there's just no way around that.
A long-lived branch with a bunch of merge commit is much more difficult to revert.
Whether you're using rebase or merge, it's just going to be a pain. So there's not like a super special strategy to get around that. By the way, so the reason why I personally like the rebasing approach is that every now and then I need to revert something, right? So if I am under really strict practice of always moving my changes to the front with rebase, I'm always squashing them down to a singular commit. If that one day does happen to come by where you actually messed up production a little bit, a singular commit with no merge commits, with none of that, is very easy to revert. But if you have 6 commits with several merge commits in between, reverting is just more challenging, because now you're going to have to figure out how to pull out all that information and make sure that it is now updating, just a lot more. It's a huge pain. So this is why I choose this way. It's very intentional. I'm planning for failure as opposed to planning for success, which is why I use Rebase. By the way, if you like
and planning for failure rather than planning for success,
and you prefer to use it, you can actually just add it to a config. I actually don't have it set as a config. I always like to kind of manually, I don't know, but you can.
But you say git config add global pool.rebase true.
And just simply do git config add global pool rebase true, and it will always do that. Don't do that now, because, well, we're going to do some merging and then some rebasing as well. So I just want you to know that that's a thing. For now, you can just do git pull -- rebase, and it will pull it and do a rebase as
So then you're going to pull it, and then you're going to rebase your local change.
opposed to a merge.
As opposed to do a merge.
Yeah, look at that. I even warned myself because I knew I'd goof it up. It's just base, and it will pull it and do a rebase as opposed to a merge. Yeah, look at that. I even warned myself because I knew I'd goof it up. It's just so easy to do that.
Alright. So that'll be all for this video. Take care. Bye bye.